Welcome to today's deep dive. We have a really fascinating and honestly pretty surprising stack of research to go through with you today.
Yeah, we really do. It's a topic that kind of turns everything you think you know on its head.
Right. So we're looking at a dossier today. It was compiled by a physician, drawing directly from the big ones, the World Health Organization, CDC, the International Agency for Research on Cancer, and the U.S. National Cancer Institute.
All heavy hitters.
Exactly. And our mission today is to talk through one of medicine's most surprising true facts, which is that a handful of human cancers actually begin with an infection.
Which, I mean, that sounds like science fiction, right?
It really does.
The idea that a virus or a bacterium could act as the spark for a malignancy, it just challenges everything we intuitively feel about how cancer works.
Right. And, okay, before we go even 1 second further, I need to address that feeling because I know you, the listener, might be hearing the words infection and cancer in the exact same breath. And, well, you might be feeling a completely understandable spike of panic.
Yeah, that's completely natural.
So we need to settle that fear right now, plainly and humanely. Listen carefully. Lymphoma is not contagious. Cancer is not contagious.
Not at all.
You cannot catch it from a friend. You can't catch it from a relative or a partner. Nobody's cancer is anyone else's risk. We have to draw a hard, impenetrable line here.
Right. The germ might spread, but the cancer never does. That is the absolute foundational rule for everything we are going to explore today. Cancer is, it's an internal misfire of your own cells. It is not a contagion.
But there is a twist, right?
There's a twist, yeah. And it's a profound biological reality. We're going to explore how certain ordinary viruses and one specific bacterium can actually, over a period of many years, help start specific cancers.
But only in a very small fraction of the people they infect, right?
Exactly.
A tiny fraction.
Okay, let's unpack this. Because if the cancer itself isn't catching but the germ is, how did we even figure out that a germ was acting as the spark? Well, for that, we have to go back to the late 1950s. There was this surgeon named Burkitt working in equatorial Africa, and he started noticing a very specific aggressive jaw tumor in children.
And he mapped it, didn't he?
He did, which seems basic now, but it was revolutionary. He drove thousands of miles, mailed questionnaires to local hospitals, and plotted every single case on a map. But the pattern he found was, well, it was impossible.
Because it followed the mosquito zones, right? Like the malaria belt.
Exactly. It perfectly tracked the temperature and rainfall patterns of the malaria belt, which makes zero sense because cancer doesn't care about bugs.
Unless the cancer is somehow tied to a transmissible infection.
Right. It was a massive clue.
Yeah.
And it sparked a global search. A few years later, in 1964, scientists in London, Epstein-Barr, and Barr, looked at these Burkitt lymphoma cells under a microscope and found a brand new herpes virus hiding inside them.
Epstein-Barr virus.
Yes, Dean. The very first human cancer virus ever discovered. And this specific disease, now called endemic Burkitt lymphoma, is highly tied to it. But the malaria is the crucial cofactor.
Because malaria in that region is holoendemic, right?
Yes.
People are constantly exposed to it from birth.
Exactly. So the immune system is dealing with this massive chronic distraction. Now, EBV specifically targets B cells.
Which are basically the body's antibody factory.
Right. They're a core part of the immune system.
Right.
Normally, your other immune cells keep the EBV asleep inside those B cells, but the malaria suppresses the specific guards that are supposed to be watching the virus.
Oh, I see.
With the guards distracted, the EBV wakes up and drives those B cells to divide relentlessly. And when cells divide that frantically, mistakes happen, and a malignant clone can emerge.
So if the malaria is the distraction, like pulling all the security guards away to the front of the bank, EBV is the thief that sneaks in the back and cracks the safe.
That's a perfect analogy. It's a devastating synergy.
But wait, this brings up a massive paradox from the dossier. EBV causes mononucleosis, right?
Yes, it does.
And practically everyone has it. Like 9 out of 10 adults globally carry EBV. If almost all of us have this thief sitting in our bank vault right now, why is this lymphoma so rare?
Because of a concept we call necessary but not sufficient. The germ is just one ingredient.
Just one ingredient.
Right. EBV is successful because it hides. It goes into latency inside your B cells, totally invisible to the immune system. For most of us, it's just a harmless passenger. For it to trigger cancer, it needs a perfect storm of cofactors. The virus is necessary, but absolutely not sufficient on its own.
Which makes sense. I noticed the dossier talks about this with classical Hodgkin lymphoma, too. EBV is found in the malignant cells there, but I remember it explicitly saying we shouldn't quote a single number for how many cases are tied to it.
Yes, exactly. That is so important. The share of classical Hodgkin lymphoma tied to EBV is completely variable. It is never fixed.
Because it shifts so much, right?
Right. You have to say the fraction varies by place, age, and subtype. It's completely different in high-income countries versus resource-poor regions. Pinning down one number would just be biologically inaccurate.
And speaking of Hodgkin lymphoma, I want to interject with something from the research just to reinforce our core rule. Because decades ago, scientists noticed what they called space-time clustering with Hodgkin lymphoma cases.
Oh, yes. The whisperings of an outbreak.
Right. People saw clusters and understandably panicked, thinking it was contagious.
Which is how human brains work. But we have to be crystal clear. That was a cautious early hypothesis that was totally discarded. The EBV virus is ubiquitous and spreads, but the cancer does not. Hodgkin lymphoma is never passed person to person.
Perfect. It's so relieving to have that stated so plainly. Now, if EBV is a co-conspirator, what about a virus that is a prime suspect? The dossier jumps to 1980 and introduces a virus where, without it, the cancer literally does not exist.
HTLV-1.
Yes, human T-cell leukemia virus type 1.
This was monumental. It was the first human retrovirus ever identified. And it is the necessary cause of a rare aggressive disease called adult T-cell leukemia-lymphoma.
Okay, pause for a second. We hear retrovirus a lot, usually with HIV. What makes a virus retro?
Well, a standard virus brings its own instructions, hijacks your cell, prints copies, and usually destroys the cell. A retrovirus operates in reverse. It brings RNA, reverse engineers it into DNA, and physically splices that DNA into your own cellular genome.
It literally writes itself into your permanent genetic code.
Exactly, a permanent edit.
Yeah.
And HTLV-1 targets your T cells.
But here's my question. If it's the necessary cause, the dossier says only 2 to 5% of carriers ever actually develop the leukemia-lymphoma decades later. Why are the other 95% fine?
Because cancer is incredibly hard to make. It's the ultimate slow burn. HTLV-1 provides the spark, but it takes decades of accumulated damage to build the fire. Those T cells replicate a bit faster, a bit more recklessly, over 30 or 40 years. They have to mutate, escape immune surveillance, and survive. Most of the time, they just don't make it that far.
So mechanically, how is the virus pushing the cell toward malignancy? The research talks about direct versus indirect mechanisms.
Right, two distinct ways. HTLV-1 and EBV are examples of the direct mechanism.
Where the virus is actively pulling the levers inside the cell.
Precisely. It's inserting its own cancer-causing genes. It steps hard on the cell's gas pedal, forcing division, and it actively cuts the brakes.
Cutting the brakes meaning it stops the cell from naturally dying off.
Yes. Healthy cells have a suicide program for when their DNA is damaged. These direct viruses block that program, trapping the cell in reckless, immortal division. KSHV, which causes Kaposi sarcoma, does this too.
So direct transformation is like a hijacker, violently taking the steering wheel, slamming the gas, and locking the doors. The virus is actively driving the car off the cliff.
That's a great visual. But then there's the indirect mechanism, which is completely different. The germ isn't even in the tumor cell.
So how does it cause cancer if it isn't pulling any levers?
Through chronic inflammation. The germ sets up shop and relentlessly provokes the immune system for years. The body is in a perpetual state of emergency. Immune cells are constantly rushing in and dividing rapidly, just creating absolute chaos.
So if direct is a hijacker, indirect is like a screaming passenger in the back seat. They aren't touching the wheel, but they're distracting the driver for so long that eventually the driver makes a fatal mistake and crashes.
Exactly. Purely by chance, a genetic typo happens out of the chaos.
Which brings us to the most unbelievable part of the research. If this pathway relies on a constant distraction, what happens if you remove the distractor?
This is a story that borders on the miraculous. Let's look at Helicobacter pylori.
H. pylori, which is just a common stomach bug. It causes ulcers.
Right. It colonizes the stomach lining and creates that chronic inflammation.
Yeah.
Eventually, out of that immune chaos, a cancer can arise called gastric multi-lymphoma.
A stomach lymphoma?
Yes. But because it's driven entirely by the immune system trying to fight the bacteria, doctors in the 90s discovered something breathtaking. If you catch it early, you don't necessarily need chemotherapy. You give the patient antibiotics and an acid-suppressing drug.
Hey, you just kill the stomach bug.
You eradicate the H. pylori, the screaming passenger is kicked out, the immune system realizes the threat is gone, stands down, and the lymphoma literally goes into remission.
That is just Oh, wow. Imagine being a patient terrified of a cancer diagnosis and your doctor says, we're going to cure your stomach lymphoma with antibiotics by clearing a bacterial infection.
It's an unbelievable triumph. And we see the exact same thing with the hepatitis C virus.
Really?
Yes, hepatitis C is linked to certain non-Hodgkin lymphomas. But today, we have revolutionary antivirals that can cure hep C in weeks.
And what happens to the lymphoma?
When you cure the hepatitis C virus, the lymphoma can literally melt away.
Just melt away.
Exactly. The biological process just unwinds once the viral stimulus is gone.
Okay, I have to ask. Curing cancer with antibiotics, viruses causing tumors, is this fringe science? Is this universally accepted?
It is the global consensus. The dossier grounds this in the ultimate authority, the IARC, the cancer arm of the World Health Organization.
The global gold standard.
Absolutely. They reviewed decades of evidence and placed Epstein-Barr, hepatitis B, hepatitis C, high-risk HPV, HTLV1, and H. pylori all in Group 1.
Which is their highest tier of proven human carcinogens, right alongside things like asbestos.
Yes, the debate is over.
So if we know they are proven carcinogens, what is the hopeful payoff here? What does this mean for us today?
Well, it leads to the most profound public health payoff imaginable, because if an infection is the necessary spark, then preventing the infection prevents the cancer.
We're talking about vaccines.
Exactly. Prophylactic vaccines stopping cancer before it can even start. Take hepatitis B, which drives a deadly form of liver cancer. In 1984, Taiwan launched a universal infant vaccination program.
And what happened when those kids grew up?
They recorded a sharp, unprecedented decline in childhood liver cancer. A simple shot given to a baby prevented an organ cancer decades later.
And we're seeing this play out right now with the HPV vaccines, right? The ones that rolled out around 2006.
Absolutely. High-risk HPV is the direct cause of nearly all cervical cancers. And the data from countries with high vaccination rates like the UK, Scotland, Sweden is just staggering. We are seeing the near elimination of cervical precancer and cancer in those cohorts.
Near elimination. That's incredible. An entire devastating category of cancer could just not exist for the next generation.
It's the closing of the circle. The same science that revealed the terrifying reality that germs can drive malignancy has handed us the tools to eradicate those cancers entirely.
Which perfectly wraps up our deep dive today. We started with the scary concept, but by understanding the nuance of necessary but not sufficient, we've seen how a frightening mystery became a hopeful triumph. We draw a firm line, an infection that spreads and a cancer that does not. Keep the tone measured, right? Lymphoma is not contagious, but by targeting the infection, we are literally stopping cancer before it starts. If you found this deep dive as fascinating as we did, please like and subscribe. It really helps the channel reach others.
And, before we go, I want to leave you with one final thought to mull over. We talked about the viruses we've already caught in the act, but considering how successfully viruses hide in our cells for a lifetime, it makes you wonder, what other completely ordinary, harmless-seeming viruses that we all carry today are quietly acting as the missing ingredient for other chronic diseases we haven't even linked them to yet?
Man, that is a wonderfully provocative question to end on. The roots of a diagnosis are rarely just what you see on the surface, are they? Thanks so much for listening, and we'll see you next time.